In part 3 of my worked example videos, I'm going to be working on some volumes. So for these, I tend to just use the formulas, assuming that I have all the dimensions that I need. In that right square pyramid, the volume of a pyramid is given as 1/3 area of the base times the height of the pyramid. Since this is a square, the area of the base is just 4 by 4, or 16. The height is given in this pyramid. I can tell that because of that right angle. It looks like a pole supporting my pyramid, is 5. So I take 1/3 of 16 times 5, which is 80 thirds, or approximately 27 centimeters cubed. How about that right circular cone? Well, the volume of a right circular cone is given as 1/3 pi r squared, that there's your base area, times your height. Well, in this case, I have those dimensions. I have the 1/3 pi. My radius here is going to be 6 squared times my height. Oh, wait a minute, I don't have the height. So I have to work on this triangle inside here using the Pythagorean theorem to find out what that height is. Now, you might just know that height, or you might be able to do the Pythagorean theorem very quickly. But we know that 6 squared plus 8 squared equals 10 squared, and I'll leave you to solve that and come up with the height of 8. Someone else might recognize this as a 6, 8, 10 triangle, one of those special right triangles that we see a lot, a Pythagorean triplet. So my height, 8. When I multiply that out, I end up with 1/3 36 times 8, or 96 pi centimeters cubed. Again, volumes are all centimeters cubed units. Well, how about those combination shapes? Here we have a right circular cylinder with a hemispherical cap. So I'm interested in the volume here. When I look at the volume of the cylinder, so I write cylinder volume, that is just pi r squared times h. The diameter is 20, so my radius is 10. So I'll have 100 pi times h, which is 60, or 6,000 pi. I can add that volume to the volume of my hemisphere on the top. I know that the volume of a sphere is 4/3, that's a 3, pi r cubed. But this is half of that, so I'll stick a 1/2 in front, cancel that down to 2/3 pi r cubed. What is the radius of that hemisphere? Well, the diameter is 20, so my radius is 10 again. So I'll get 2/3 pi times 10 cubed, or approximately 10 cubed, of course, we know is 1,000. So we get 2,000 pi over 3. We can maybe give that as a rough estimate of around, well, I don't know, maybe we don't want it as a rough estimate. Let's just go ahead and add these two together, and that is the total volume in feet cubed of my figure shown. Finally, as we go down to letter D, again with the volume, this looks like a rectangular prism on the bottom with some sort of triangular prism on the top. So what is the rectangular prism volume? Well, that's just base width height, so 30 times 40 times 15, which gives me 18,000 feet cubed. Well, how am I supposed to find that triangular prism on the top? Well, if I maybe redraw this line in here of a 40, what is the volume of my triangular prism? Well, it's just going to be area of this base times its height. So I take the area of that base, I'll stick a 30 in there, and the area of that base, which is a triangle, is 1/2 base of 30 times height of 8, or it would be 30 times 4, and I'm coming up there with a 120. So that's the area of my base, 120 feet squared, and now I have to take that area across the entire height of the 40. I keep calling it base and height, but in this particular case, it's like that triangular prism is kind of laying on its side. So I take that entire 120 area over the 40 height of that triangular prism. So I have 120 times 40, and I get 4,800 feet cubed. If I add those two volumes together, my triangular prism plus my rectangular prism, I'll get that 4,800 plus the 18,000, and I get a total of 22,800 feet cubed.